How's everybody doing? My name is TJ Lair, and welcome to Connect Real-Time Data to Amazon Redshift with Confluent.
Hi everyone, Joseph Bonais, Cloud Partner Solutions Architect here at Confluent. Happy that you're all here with us today.
Awesome, so I want to start with a quick agenda slide. We're going to go through a few different sections of the presentation. The first one is all around context setting. So the why, the what, the who. Confluent is obviously not a data warehouse technology, so we augment and complement your data warehouse technology. And then Joseph is going to break it down to the bits, where he'll go through the proposed architecture that we see across a whole bunch of different customers and the specific Confluent tech that goes along with it. And then we'll jump into a demo so you can see what this looks like in real time. And we'll finish up with a little Q&A if we have time. Otherwise, we'll be in the hallway after the session and can take your questions then. So starting with the context, let's jump in there. So I can't talk about a data presentation without talking about the mass volume of information that's being generated. So 175 zettabytes of data is going to be generated by 2025. I personally believe it. Getting notified every time I take a picture of my newborn saying my phone is out of storage, and that's just an individual consumer's data footprint. Now magnify that out to a business consumer footprint where your employees are interacting with a whole bunch of SaaS applications, databases, data warehouses, and then your customers on the other side interacting with your product, interacting with your support, interacting with your online portals. And what we're seeing from a business standpoint is a lot of that data that's being generated, and if it's being used for analytics, it's landing in a cloud-based data warehouse. And for good reason, too. Cloud-based data warehouses decouple storage so that you can manage your costs more effectively. So when you compare it to on-prem data warehouses in the traditional sense, it's a 50% more cost, or it's a 50% cost savings or cost reduction than your on-prem data warehouse. And what you can do with the data is also pretty massive in terms of business ROI. So it's from a few different reports, we've seen a 600% ROI from using a cloud-based data warehouse. And that there's two different angles to that. One, the costs are obviously lower, and then two, the analytics that you can run on top of it are higher. And this unlocks a whole bunch of different business use cases across a wide variety of verticals. So whether you're trying to do demand forecasting for your retail store so that you can get ahead of the supply chain bottleneck that currently exists, or whether you're trying to detect fraud at a global scale across all your customers, a lot of that information will reside in your cloud data warehouse. So how can we get there in real time? But moving to a cloud-based data warehouse doesn't have its challenges. So when we talk to our customers about migrating their on-prem data warehouse to the cloud, there's a few different challenges that arise. First is just the cost argument, right? So when you do move your data, you aren't really selective with the amount of data that you're actually storing. Your Teradata instance on-prem has been around for 10 years, so a lot of people are just doing these lift and shifts over to the cloud data warehouse, ballooning up their cloud data warehouse spend, and maybe they go, I got an idea, let's create a data lake, or let's land in an operational data store prior to it landing in that cloud data warehouse, and that further extends the costs associated with your overarching data warehouse infrastructure. Next, these systems are built on a batch-based paradigm, right? So moving data from source system A to your cloud data warehouse or moving it across environments happens on a daily, a weekly, a monthly cadence. So it's very slow for folks that are already in your cloud data warehouse to get that real-time analytic ready data at their fingertips. And that's the last thing you want to have happen, especially as you're trying to change their behaviors from doing their queries, doing their analytics on-prem to the cloud. You want them to have the freshest analytic ready data. And all these problems further compound when you have to support multiple environments, when you look at security, consistency, overall management. So what we're proposing and what Confluent is really good at doing is setting data in motion. So let's first take a look at our technology, and then we'll discuss how this fits into the larger picture of your data warehouse strategy. So for folks that aren't familiar with data in motion takes the computer science of underlying traditional databases and really flips it on its head. So instead of passively storing data and only accessing it periodically, the principles of data in motion allows for ubiquitous access to data from any system as it's generated and provides the real-time continuous processing needed to react and respond to it in the moment. So having data in motion as the centerpiece of your strategy and helping harness data in motion for these migration and modernization initiatives is really, really beneficial. So how do we bring this to life for our customers in terms of technology? So Confluent offers a cloud-native, complete, and everywhere platform that can live anywhere, so on-prem or in the cloud or across multiple clouds. So from a cloud-native perspective, we have fully managed capabilities. It's an elastic service, and it's fully integrated with AWS networking, security management, all accessible via AWS Marketplace. It's complete because we extend the open source Apache Kafka project to make it more reliable and enterprise ready. And then we also make it easier for you to run new stream processing workloads within Confluent. So whether that's our connector ecosystem or whether that's KSQL DB that allows you to quickly build streaming analytic applications using SQL. And then everywhere, every one of our customers usually gets started with Confluent Cloud because of the ease of use, but we do have a self-managed offering that you can deploy on-prem. This allows you to create that bridge from on-prem to AWS or across multi-cloud environments so you can quickly migrate and modernize your data platform. And we'll discuss what that looks like in more detail. So let's first take a look at what this looks like when you plug Confluent's platform into the data warehouse architecture that we looked at earlier. So when you do this, you reduce the total cost of ownership when you look at your total data warehouse TCO model, right? By being able to process a whole bunch of information in stream prior to it landing in your data warehouse, you can carve down the amount of data that you actually land in that cloud DW. Also, with our fully managed capabilities, the pipelines associated with the data that's flowing into your data warehouse are also lowered. This allows you to power net new analytics and applications using on-prem and cloud data. So that's very, very important. When you're building these net new applications using Amazon Redshift or directly within Confluent, Confluent can live across those two environments so that you can have access to that information to stream process that information and then also build those net new applications. And then you can also extend your cloud data warehouse from a connectors perspective, so the amount of data that you're connecting to. So if you want to connect to an IoT device using MQTT, or you want to connect into an Oracle database that lives on-prem, you can use one of our 120 pre-built connectors. So let's drill into these in a little more detail so you understand the full context behind each one of these. So from a TCO perspective, when you think about your data warehouse, you need to think about it holistically, not just your data warehouse spend, but also the systems that support your data warehouse. And you can't think about all those different systems without thinking about data pipelines. So when you compare Confluent Cloud versus traditional ETL or MQ systems, we see a significant reduction in cost from a TCO perspective. We also see managing their cloud data warehouse spends more effectively for these large-scale joins, aggregations, building materialized views, and pushing that down into Confluent so that you can do that in stream. And one of our customers has seen, or they expect to see, a 10x ROI over the next 3 years, making the shift from traditional to cloud-based data warehouse using Confluent alongside it. In terms of connecting to all the different systems, there's a few different points I want to make here. One point is around new applications. So when it comes to connecting to new applications or building new applications, Confluent has pretty much any programming language that you want, you can build on top of Confluent so that you can extend the data and send it out to net new applications or send it out to your cloud data warehouse. You can also connect to existing or legacy applications, right? We mentioned Oracle earlier. Imagine your mainframe as well, your on-prem Hadoop environment. So being able to take all that information and move it directly into the cloud continuously as it changes on-prem gives you that stepping stone instead of trying to untangle a 10-year on-prem data warehouse that's very, very difficult to migrate. And then finally, is around the cluster linking capabilities that I mentioned before. So being able to take that data, connect it from a wide variety of distributed systems, no matter where it lives, and move it directly to the source destination that you want. So the next point I want to talk about is just the scale of our real-time event processing capabilities. So when you look at Confluent in this 4x4 quadrant, you see kind of the unique position where we land. The high throughput, low latency data processing is our sweet spot. And that's largely due in part to Apache Kafka being distributed in nature so that you can scale to massive, massive volumes. some of our customers are running applications through Confluent at the scale of 30 to 35 billion events per day, and they're reaching peak throughput around a million events per minute. So you can imagine that kind of scale being applied to multiple different applications and moving all that information directly into the cloud data warehouse of your choice. And I know it's not a fair comparison, right? Confluent versus Redshift are two very different systems and technologies. But imagine the difference between doing some of these large joins and aggregations and building materialized views in a cloud data warehouse compared to Confluent. We're talking minutes to milliseconds, right? So being able to push those business-ready queries down into Stream is extremely important so that you can manage those costs. And we have customers doing this across industries, financial services, retail, and across geos as well. So KeyBank is one of our customers where we connected their on-prem Teradata instance into their next-gen cloud data warehouse to make it easier and facilitate a streamlined migration process. Sykes Holiday College, like we mentioned already, expects a 10x ROI over the next 3 years, and they went with Snowflake on AWS plus Confluent. And then Newly, who is a division of Urban Outfitters, expects to see a reduction in management costs by 10x. So when you look at your cloud data warehouse architecture and you're thinking about how do we accelerate this migration from on-prem to cloud, Confluent is definitely a way to help that across a few different avenues. So with that, I'm going to pass it over to Joseph to break it down to the bits.
Thanks, TJ. I feel like it's very appropriate that our director of marketing set up all the problems, and now I got to go over all the fixes, right? So, all right, let's break it down. So, this is a bird's eye view of an architecture featuring Confluent cluster linking with either Confluent Platform or Apache Kafka from an on-premise to fully managed Confluent Cloud in AWS. By replicating events into Confluent Cloud, we can bridge our data centers to the cloud in order to take advantage of native cloud services. Let's take a closer look at the technologies featured here. We'll go through each technology during its alignment with our three-phase plan. In our first phase, we will use Confluent for Kubernetes and cluster linking to migrate and liberate our data from on-premise. Next, we'll use ksqlDB to optimize and combine our data sources. Finally, we will modernize by syncing data into Amazon Redshift using a fully managed Confluent connector. Confluent cluster linking will help us put our data in motion and allows us to connect all of our sites, edge, regional, headquarters, etc., together to form a global data mesh. Data is syndicated and replicated between on-prem and on-prem, cloud and cloud, on-prem and cloud, edge and cloud, and any mix that fits your outcomes. All of this is achieved by leveraging the internal replication mechanism of Kafka and preserving offsets between source and mirror topics. Though not necessarily required for data warehouse modernization, offset preservation is helpful in some multi-region cluster or disaster recovery scenarios. Here's a quick breakdown of cluster linking versus incumbent replication technologies. I already mentioned that cluster linking utilizes Kafka's internal replication mechanisms and preserves offsets, but there are a couple of cons. First, we do not support single message transforms, which allows us to make minor changes to events in flight. This kind of makes sense because in cluster linking, we mirror topics. So we're trying to have a byte by byte copy, so changing messages in flight really doesn't fit that paradigm. Second is we cannot repartition on the destination for the same reason. Both MirrorMaker 2 and Replicator require the use of Kafka Connect in order to function, so cluster linking does not. So you can harness powerful replication and simplify your stack. Kafka Streams is an API of Apache Kafka that allows us to build applications in either Java or Scala to do things with events in real time. You could, for example, filter out events from one topic and then place them into another topic. Confluent has built an abstraction layer on top of streams called ksqlDB. In our novel example here, you can see how much easier it is to achieve the same outcome with ksqlDB compared to a client Kafka application or even a Kafka stream. ksqlDB supports joins, aggregations, windowing, exactly once semantics, and much more. ksqlDB separates compute from storage and is independently scalable from brokers and fault tolerant. By intention and design, Kafka is the backbone of KSQLDB. KSQLDB reuses Kafka as the foundation for KSQLDB's own elasticity, fault tolerance, and scalability. That's why KSQLDB scales so well, why it's so resilient, and so forth. It also means that improvements made to Kafka also benefit KSQLDB. Something that is extra awesome is that KSQLDB is available as a fully managed service in Confluent Cloud. This means you do not have to worry about the infrastructure or the operational tasks like running servers, scaling, upgrading from version to version, and monitoring, and so on. Let Confluent, us, worry about the undifferentiated heavy lifting while your engineers build the data in motion applications of the future while only paying for what you use. So it looks like we might have duplicated a slide here. I'm not sure how that happened. So, moving on. Looks like we caught a couple there. All right, there we go. I'm not sure what happened to our slide deck here. It looks like some of our slides were duplicated. I apologize. So, sorry, I think we already got through this one too. Am I just like
Are you going
through
backwards?
the same? What's that?
Are you going backwards?
Oh my God, I'm so sorry.
Problem
There are two
solved.
buttons here, and I'm pressing the wrong button. I appreciate that. All right, so there we go, we're back on track. All right, so once you and your teams have all these awesome streaming applications running in KSQLDB, we have some tools that will make these applications even easier. The first is our stream catalog, which is a knowledge base for data in motion. It's like the company's public library for event streams. The key idea here is to centralize all Confluent-related metadata from any of your clusters. With all this real-time processing we're gonna do, it's important to determine where did my data come from? Where is it going? When, where, and how was it transformed? That is what Stream Lineage does, providing a GUI to give you the answers to those exact questions. Finally, stream quality via our schema registry ensures that events have proper fields and field types, provide mechanisms for schema evolution without interruption, and in the near future will provide validation based on business rules. So you want to build all these excellent microservices using Confluent as the event layer. Let's first take a look at various supported clients. I'm sure these will cover most of your use cases. However, I have no doubt that somebody out there is laughing about your 20-year-old Fortran application. We do have an answer for that, which we'll cover in the next couple slides. But in addition to this bevy of software clients, we also have REST and MQTT proxies. But now let's shift our focus to Kafka Connect. There is another API of Apache Kafka called Connect. It allows you to pull events from different systems into Kafka. We call those source connectors. And you can also take events and send them to other systems downstream, and we call those sync connectors. There are a number of open source Kafka connectors out there in the wild. Confluent has expanded on these open source connectors to further increase the number of available data sources and syncs in order to move data in and out of Kafka. A developer working with open source Apache Kafka will have two options. Develop their own connectors using the Kafka Connect framework, or leverage the aforementioned open source connectors already built by the community. The challenge with the first option is the time and effort it takes. In 2019, Confluent increased its connectors portfolio from around 10 to over 100 supported connectors. Through this experience, we measured it takes an average of 6 weeks with a full-time engineer to develop one connector. And this is the time it took the world's Kafka experts. The challenge with the second option is that all of these open source connectors will be unsupported. This would generate significant risk for an organization deploying Kafka and event streaming into production. What would happen if something breaks? Would the organization feel comfortable with fixing these issues without help from the experts? This is why Confluent offers a portfolio of over 130 connectors, around 100 of which are developed by us directly, and another around 30 are developed and supported by our partners with full validation from us. You can run these connectors anywhere using Confluent Platform or fully managed on Confluent Cloud. During our demo, in just a few moments, we'll be featuring our Oracle Change Data Capture connector, which will allow us to efficiently add data stored in Oracle to our real-time data pipeline. For anyone out there running the 20-year-old Fortran application, this is how we get the data. We would use one of our connectors and pull the events from your application from the source. It's probably some form of database, a mainframe, we have connectors to all of that. So we do have an answer for that old piece. So before we get into the demonstration, I wanted to quickly reiterate that many of the Confluent connectors are available fully managed in Confluent Cloud. Again, let us handle the scaling, the integration, and the uptime so you and your teams can focus on building out new real-time applications. We'll be featuring our fully managed Postgres source connector during the demo. All right, let me get over here. Make sure I'm pressing the right button. All right, so let's take a look at a pretend retailer. We'll call them Blue Mariposa. Let's look at how they go about their data warehouse modernization journey by migrating data from Oracle and Postgres to Redshift. Let's say Blue Mariposa uses Oracle on-prem to store most of their business-critical stuff like customer data. However, they have online orders in a cloud instance of Postgres. Maybe another line of business owns that data stored in Postgres, or they haven't completely completed an acquisition or something, right? But the point is that they got some data in silos across on-prem and cloud environments, which is common for a lot of organizations. That's preventing them from getting a more complete and holistic view of their customers so they can create real-time personalized promotions, which is something they want to do. The data science team at Blue Mariposa is eager to start analyzing this data and generating insights, but they face a couple of challenges. First, the data they need lives in two separate systems and environments, like I said, Oracle and Postgres. And they'll need to access and merge that data in order to get a unified view of customer purchasing behaviors and preferences. Now, second, the real-time analytics is a problem data warehouses have solved, but their current data warehouse doesn't have the usability or performance necessary for the type of real-time and relatively sophisticated analytics that they're looking to conduct. So the data science team advocates migrating to Redshift, which kicks off their journey of moving to a cloud data warehouse. Using Confluent and our library of pre-built source and sync connectors, we can build and scale real-time, multi-region, and hybrid data pipelines that move data from any source to any cloud data warehouse of your choice. One second, because I'm about to go for a long time. All right. So let's go through an overview of our implementation steps. Number one, we'll set up a self-managed Confluent Platform cluster on an on-prem Kubernetes environment. Two, we'll extract customer data from Oracle to Confluent Platform using the Oracle CDC Source Premium Connector. In this demo, we're choosing to start with an on-prem environment running Kubernetes to match the environment of our Oracle database, which we already said was on-premise. But you can also connect to Oracle database directly to Confluent Cloud using the same CDC connector if you'd like. Third, we'll stream the customer data from our self-managed Confluent Platform cluster to our fully managed Confluent Cloud cluster with cluster linking. And that's another good reason why we did CDC on-prem to an on-prem Confluent installation so we could use cluster linking, which is incredibly cool and very common in this scenario that we're illustrating. Fourth, we'll extract the order data from our second data source that's already in the cloud. That's that Postgres cloud instance with the fully managed Postgres source connector, putting that data in the Confluent Cloud. I think I got ahead of myself. Five, once all this data is in Confluent Cloud, we'll merge and transform the data with KSQLDB, generating a unified 360-degree view of the customer like we've always wanted. Note that for basic transformations like filtering or masking, or things like that can be done in Kafka Connect using a feature called single message transforms, or SMTs, at the level of the source connector. Now, that's some flexibility, convenience, and potential cost savings. It's a fine thing to do, but for our purposes today, we're going to keep it all in KSQLDB because it's a more powerful and more generalizable tool, and honestly, I think it makes for a cooler demo. So, and I think it's flexible, and you'll end up using it a lot more as well. So finally, we'll load the clean and merge data into Redshift, got there a little early, using our fully managed Redshift connector, where the data science team can do their thing, like creating real-time promotional recommendations. And with that, let's take this step by step. One more time. All right. For the demo, we'll be deploying Confluent for Kubernetes, which automates deployment of Confluent Platform and makes it easy to configure all the components of our self-managed offering with the declarative API-driven experience that gives you a kind of cloud-like elasticity, but with your on-prem environment. To set up Confluent for Kubernetes, make sure you have kube control and Helm pre-installed, create a namespace to host your pods, set it to your default namespace, then install Confluent Operator using Helm. Here you can see we've enabled cluster linking as part of our deployment. Next, we'll install the platform components using kubectl. It'll take a moment for all of our pods to deploy and run, but by using Movie Magic, we can speed that up. There we go. Once all of our platform components are installed, let's head over to Confluent Hub to search for our Oracle CDC Source Premium connector. This is a self-managed connector, so we'll need to download it and bake it into the Docker image so that we can find it later in Control Center, so it'll be class loadable by Kafka Connect when it runs. So we'll run the Confluent Hub install for Oracle CDC connector. Next, let's take a look at the customer data we have in the Oracle database. In the customers table, we have fields like customer ID, customer name, and some other customer information. We're going to be using customer ID field later to match our customer data to the customer's order. In Confluent Control Center, we can see the Confluent platform cluster that we just deployed through Kubernetes and the Oracle CDC Source Premium connector. We'll supply all the necessary settings to access our Oracle database. This connector allows you to pretty reliably and cost-effectively implement continuous real-time syncs by offloading that data, getting that data out of Oracle database and into Kafka topics. Once you've created the connector, check back to make sure the connector is running. It's always a good idea. Now, let's check out this new topic, oracle.admin.customers, created by the connector to see the records coming from Oracle. With our pre-built connector, you've now performed a highly complex integration that would otherwise take more than a few engineering months to replicate in-house. Trust me, this is trickier than it sounds. It's great to have connectors. Next, we'll bridge our two environments, from our self-managed cluster with Oracle data to a fully managed cluster on Confluent Cloud using cluster linking. Let's start by provisioning our Confluent Cloud cluster. We'll select getting a little ahead of myself. We'll select a cluster type, begin configuration. We'll select a cloud provider, AWS of course, a region, availability zones, and launch the cluster. To enable cluster linking and mirror the on-prem Confluent Platform cluster to the new Confluent Cloud cluster we just created, make sure your destination Confluent Cloud cluster has cluster linking enabled. Using the cCloud CLI, we'll create a destination-based cluster link, and we'll create a mirror topic on the destination cluster to associate it with the cluster link. Let's go into the Confluent Cloud UI now, and you can see, getting here a little early, okay. You can see our topic now exists in Confluent Cloud as a result of that cluster link. Pretty cool stuff. Now let's switch gears and examine our second data source, which is data in Postgres in that cloud instance of Postgres. Let's take a look at the orders table. It has fields like customer ID, product name, order, date, and cost. We'll need to get this data in the Confluent Cloud as well, which we'll do using our fully managed Postgres source connector. Unlike that self-managed Oracle connector that we used earlier in Kubernetes, this fully managed Postgres connector in Confluent Cloud extracts away all the operational burden. So we can get started quickly with just a little bit of data entered and literally just a few clicks. So we'll tell the connector about our Postgres database, launch it, and validate that it's created a new topic. It's a happy thing. And there's our topic, Postgres_orders. Now that our connector is up and running, let's take a quick look at the topic it created, which is Postgres_orders, and check out the events that are there. Looks like they're there. Once all of our data is in Confluent Cloud, it's time to merge and transform it using ksqlDB, which lets us do real-time stream processing with SQL. Let's first create a new ksqlDB application. That's the place where our queries live, and write some queries. First, we'll create a stream of customer data from the customer's topic. And now we're going to create a stream with the orders topic. Then we'll merge the two streams together on the common customer ID field. Next, we'll begin cleaning the data. We want to clean the data here in Confluent because the clean data can then be used by multiple downstream applications in the systems without needing to re-clean it and reprocess it over and over again. So let's start by scrubbing the data. Let's start by scrubbing the customer data from Oracle. We'll need to create a table from that stream. That's what customer data is. Customers are things, so they're going to go into a table. But we may not want to provide certain sensitive data on a customer to the data science team. So let's remove fields like preferred credit card number. And hopefully that was encrypted anyway, but we won't even include it. Next, we'll want to create a table that aggregates certain metrics from the order data in Postgres. The data science team often wants to see variables like total number of orders or total lifetime spend for each customer. So why not just aggregate the data in real time? We'll aggregate the count of order ID and the sum of order amount by customer ID to create two new fields. We'll also want to know when the customer's most recent order was. So let's create another field called last order and with the most recent order date. With the data clean, let's join the customer and the order data from the two data sources using the common field customer ID so we can get a unified view of our customers. We don't need to load customers who haven't made a purchase in the past 5 years or longer into Confluent Cloud, into our cloud data warehouse. I think that seems fair. So we'll filter those customers based on last order field and save on storage cost with the data warehouse. Now that we have our clean, unified view of the customer, let's load this into Redshift using Confluent's fully managed Redshift connector. Similar to the Postgres connector we used earlier, it's a quick and simple process to launch a fully managed connector. Let's tell the connector all about our database, all about our Redshift data warehouse, the domain, username, password, database name, and launch the connector. With that connector fully provisioned, let's go over to Redshift and see what happened. We could see that all the data is here. We won't go through all the details, but it's sufficient to say that we've taken our data from our legacy database, bridged it from on-premise deployment to a cloud environment, joined it with other valuable data, and processed it with ksqlDB, then floated it down to Redshift, where our data science team would be able to accomplish and conduct all their growing analytics concerns and operations. There you go.
Awesome. Thank you so much, Joseph. So looking at the clock here, we have 3 minutes. If there is a question, you can yell it out. Yes?
What's ksqlDB? What's behind it? Is it a memory database or?
Oh, such a good question. So,
Well, Joseph, sorry, just to repeat it back to the folks
sorry
viewing
about
at home. What is ksqlDB?
right. So I mentioned Kafka Streams has this API that allows us to build these Java applications or Scala applications to do things in real time. So we have built a layer on top of that that extracts all of that into that SQL-like interface. But it's running its own processing, and it stores its state in RocksDB. So there is a persistence layer. So you're not querying from the topic every time. It's a great question. Any other questions? I think I see one over there. Sorry, these lights are really bright. Yes, absolutely. If you look at our Confluent YouTube page, there is a very similar demo, ultimately syncing into Snowflake.
Your demo running a linked cluster and having the connectors run on-prem, like what's the advantage of doing that versus just running all your connectors in the cloud?
Great question. So there's a question here about running connectors on-premise. Why do we run them on-premise as opposed to in the cloud? So there's a couple reasons for that. One, you may want to share the Oracle data on-premise with other systems. You could do an Oracle upload. So instead of having everything up in the cloud, there's a good reason to have your data there. You may also have some filtering use case where you want to not necessarily have certain data leave Oracle. So you can have your on-premise cluster, you could have a KStream there. We didn't do that. We did everything in the cloud, but you could have a KStream app on-prem that filtered out data before even sending it to Confluent Cloud. So it really just depends on your use case. But you absolutely could just do everything in the cloud if you had the right connection between Confluent Cloud and on-prem. Yes, it would be lower latency in terms of getting it into the Confluent platform, the on-premise. That would be much lower latency than likely any connection you could get directly to AWS or another cloud provider. But again, it just whatever your requirements are. Do you see any others out there, TJ?
The
Oh, sorry, I think someone got before that, right there in the middle. Hi. The support. Great question. So the question was about Confluent's support of our connectors. So, one of the biggest value props I think we have is that we have all these, this huge number of connectors, but the other piece is the support behind it. So these connectors that we have that are either fully managed or available through Confluent Hub were either built directly by us or by one of our partners and validated by us, which means that our technical support staff are experts at troubleshooting Kafka Connect and then the subsequent integrations. So if you were to put a system using our connectors into production and you have an outage type of scenario, we have an entire support structure, a whole tiered support structure that can quickly address those. And we could pull in our partners if it's one of our partner connectors as well. And right here, yes. It does not. It does not. It's CDC right today. The question was, does the Oracle connector rely on Golden Gate? And it doesn't. As a matter of fact, it kind of takes Golden Gate out of this picture. Question right here.
So there are three different ways to accomplish what you kind of do. One is Kinesis, Firehose, another one is Managed Kafka, and the third one is Kafka. Can you name a few advantages why consumers would want to go with Kafka?
Okay, so there was a question here about different ways to do this. I think really kind of calling out some of the AWS native services like Kinesis, MSK, and then of course Confluent. I would separate Kinesis from the other two because Kinesis you can only run in AWS. I think Kinesis is a fine service, but if you had like an on-prem requirement, you're now going to have to bridge your on-prem and you're going to write completely to Kinesis. I would also argue potentially that the adoption across industry of so now, if you look at MSK versus Confluent, I think there's quite a few differences. Our offering of connectors, MSK does offer Connect, the MSK Connect, but they don't offer the connectors. So they'll bring up the workers for you, but you have to find the connectors. I think that's a big part of it. Support for MSK, versus Confluent, our SLA is a little higher. We also do not exclude Kafka out of our SLA. So if anyone takes a look at that, our support. Sure, I think I came from Amazon support in an old day, so I'm a big fan of enterprise support or support general at AWS. But Confluent, our support teams, they're only talking about Kafka all day, every day. So if Kafka is an important part of your stack, for some companies, it's the only part of their stack, or the main part of the stack. Having a team that thinks about and works with Kafka all day, every day, and can ultimately escalate to the majority of the committers to Apache Kafka is a pretty comforting feeling. There's a whole, I could probably have a whole conversation with you about that.
When does your cloud offering, does it run is it a SaaS model or can it be installed in a consumer VPC?
So there was a question about, is Confluent a SaaS model or can it be installed in VPC? The answer is both. So Confluent Cloud is our SaaS offering. It's available on all clouds, and you can spin up a cluster right now. But Confluent Platform can run anywhere. So it can run in your VPC, on-premise, it can run in a Raspberry Pi, almost anywhere, yeah. Great question. Do we have any other, sorry, these lights are blinding me? Yes, got it here. Absolutely. So the question was, is this for real time or can we use this in batch? The answer is that it's really around real time, but there's no reason you couldn't use this in batch because think about what Kafka is at its heart. It's a producer-consumer, right? So you could produce the topics and your consumers could fire off in some type of schedule, and make it more batch-like. So it really has the flexibility to do both. I have a question over here. Do you mind stepping up? I'm sorry, it's a little hard to hear you. Got you. So the question was really about like what kind of features you can get out of KSQL DB. So in the use case over here, it seems like they're writing some advanced business logic into Redshift. Could they move that up the stack to KSQL DB? Great question. So it's pretty powerful. I mean, that's a kind of a broad question. You know, it supports windowings, joins, aggregations. But ultimately, depending on how complex you want to get, you could say KSQL DB isn't the right fit, and I want to go with a Streams application. So Streams applications are extremely flexible, right? They're written in Java or Scala, probably less accessible, I think most agree, than KSQL DB, but you can even embed ML models into Streams. So you can get as complicated as you want, you know, with one of the paradigms, either Streams or KSQL DB, but I think if you do a deep dive into KSQL DB, you'll find that a lot, if not all, the functionality you have in Redshift is already there. I think we're at the mark where they would.
Yeah, all right, we're about to get the hook. So we're gonna leave you with one call to action, $400 free for the first 90 days if you sign up. If you visit our booth, you'll get a little bonus on top of that, an extra $100. So feel free to stop by our booth. We're gonna be having live coding sessions, live demos, a whole bunch of different experts there as well. So if you wanna scratch something down on paper and see if it'll work in your environment, feel free to join us. So thank you so much for your time and your attention, and have a great rest of your reInvent.
Thanks, everyone. Booth 220.